Hello and welcome to Mr. Tompkins EdTech. This video covers topics most likely to appear in the non-calculated paper and focusing on non-calculated methods for solving GCSE Maths problems. For students following AQA, EDEXCEL and the WJEC exam boards, the non-calculated paper is paper 1. OCR number their papers differently and it's paper 2 for foundation and paper 5 for higher tier students. I'll be covering all the essential crossover topics appearing on both foundation and higher tier papers. So this video will be great revision for both foundation and higher tier students aiming to get a good pass at GCSE. When you're ready, make sure you check out the second video which focuses on the calculator papers. You'll find a list of all the topics covered in the video description below, along with timestamps to help you navigate through the video. As you progress, I highly recommend you use the topic list to make a list of any topics that you're not sure about. Afterwards, you can then look up those topics in your revision guides or simply follow the links provided to more focused revision videos on those topics. If you find it helpful, please do like and subscribe and share it with your friends. The more past paper practice you do, the better prepared you'll be for the final exams. You'll find video walkthroughs of pretty much every exam paper on my channel, along with revisions, resources and question compilations on all those key topics you struggle with. Make sure you check those out, as this video on its own is no substitute for thorough preparation. As we run up to the exams, I'll be posting important information, predicted questions and general support and encouragement to help you achieve your target grade this summer. Good luck in your preparations and in your exams. Let's get into it.
A is a common factor of 72 and 120 and B is a common factor of 6 and 9. Work out the highest possible value of A over B. Okay, so this fraction is going to be its biggest when A is at its maximum value and B is at its minimum value, isn't it? Okay, you'll get a bigger number if you divide a fraction by a smaller denominator. So let's take B to start with then. I think that one's going to be easier. A common multiple of 6 and 9. If we want B to be minimum, we're actually asking for the lowest common multiple of 6 and 9. Okay, so let's think about the multiples of 6 and 9. The multiples of 6 are 6, 12, 18 and so on, and 9 is 9, 18, 27 and so on. So you can see we found our lowest common multiple already. 18 is there, 18 is there, so our LCM then of those two numbers is 18. So that's going to be my value of B. What about A then? We've got A is a common factor of 72 and 120. So let's list out the factors of 72 and 120. I tend to write them down in factor pairs. So 1 goes with 72. 2 goes with, well, half of 72 is 36. I think 3 must go into it then as well. So 3 and 24, is that? 3 and 24. 4 and what? 4 and that's got to be 18, isn't it? 5, no, 6. Yeah, 6 goes into it. 6 and 12. 7, no, 8, yes. 8 goes with 9. And look, I've met myself coming down the other way, so that's as far as I'm going to get. So quite a lot of factor pairs of 72. What about 120? We're going to have so many. So I've got 1 and 120. 2 and 60. 3 goes with 40. 4, yes, goes with 30. 5 goes with 24. 6 goes with 20. Also got a lot of factors. 7, no. 8, yes. 8 goes with 15. 9, nope. 10, yes. 10 goes with 12. And then I've got 11 in between. That's not going to be a factor. So that's all of them. Gosh, lots of factors for both of those numbers. So we want the HCF then of those two numbers. So we want A to be as big as it can be. So it's going to be the highest common factor of those two. So looking through my list, 72, no, 36 is my next biggest. That isn't on my list. 24, yeah, that's on my list. So look, 24 there, 24 there. So the HCF of these two numbers is 24. Okay, so what's the highest possible value of A over B then? Is going to be, so that was my A value, wasn't it? 24, and B is 18. So my highest value is going to be 24 over 18. Okay. Which I could cancel down, but I'm not sure I need to. So it could simplify to 4/3. Also an acceptable answer. Eve has these coins. So she's got a £2 coin, a £1 coin, 50p, 2 20s, a 5 and a 2 pence. Ola has these coins. She's got a £1, a 50p, a 2p and a 1p. Eve gives 3 of her coins to Ola. Now Ola has the same amount of money as Eve. Which coins does Eve give to Ola? Okay, let's see if we can work this out. Let's work out how much they've got each first off then. So Eve is starting with 2 plus 1, which is 3, plus 50p, plus 20, plus 20, plus 5, plus 2. That adds up to 3, 50, 90, 97. So Ola starts with £3 and 97 pence. Ola has a £1, 50p, a 2p and a 1p. So that is £1 and 53. Okay, so then after Eve gives Ola 3 coins, they should have the same amount. Okay, so how many coins does she give him? Well, if we can work out what the difference is between their two numbers and half it, then we'll know how much Eve gives to Ola. So what is £3.97 subtract £1.53? That is 7 subtract 3 is 4, 9 subtract 5 is 4, and 3 subtract 1 is 2. So the difference between their money is £2.44. So if I half that, £2.44 divided by 2, 2's into £2.44, 2's into 2 go once, 2's into 2 go twice, 2's into 2 go twice, so it's £1.22, isn't it? Okay, so I need to give, well, Eve needs to give Ola £1.22, and that will mean that they have the same amount of money. So if she gives the pound and the 20p and the 2p, that's £1.22, isn't it? Okay, and then they'll both have the same amount of money. Eve will have £2 left, and the 50 and the 20 and the 5p, making £2.75, and Ola will now have £2 and the 50 and the 20 and the 2 pence and the 1 pence, which is £2.75 as well. Okay, so how am I going to write that down? Oh, I need to write down in the answer box. So she's given her a pound, a 20p and a 2p. So the pound coin, the 20p coin and the 2p coin. Tom invests £2,000 at 5% per year simple interest. How much interest has been paid after 6 years? Okay, now note this is simple interest, not compound interest. We are not putting the interest into the account and then in the second year calculating the interest on the original amount plus the previous interest. It's just going to be the same amount each time. So if 100% of something is £2,000, then what's that? 10% would be 200, 5% is going to be 100. Okay, so that's what 5% interest would be. Now we're going to apply that 5% interest 6 times over because we've got 6 years to do it. So our amount, how much interest has been paid after 6 years, is just going to be 6 lots of £100, then, isn't it? Which is £600. Part B says Tom receives a 20% wage increase. His new weekly wage is £360. Calculate his weekly wage before the increase. Okay. So with percentage questions, I often do these triangles, FOM, just to keep track of what I have to multiply or divide by what. So F stands for final, O stands for original, M stands for multiplier. You can apply it to all sorts of percentage questions. So then we just need to go through and work out which is which. So he receives a 20% wage increase. His new weekly wage is 360. And we want to work out his weekly wage before. Okay, so final is what it was at the end, so that's going to be his new weekly wage, isn't it? So that's going to be 360. The original, well, that's what we're trying to find, his weekly wage before the increase. And then the multiplier is going to be the 20% increase, isn't it? But remember, we start with 100%, so if we increase it by 20%, we're now at 120%, which is a multiplier is 1.2. Okay, so now we cover up the thing we want to find. So I want to find the original, and then that tells me what to do with the other two. So using my little triangle, original equals final over multiplier. In other words, it is 360 divided by 1.2. Okay, to make things a little bit easier for ourselves, I'm just going to multiply top and bottom by 10. So that's 3,600 divided by 12, because it's a non-calculated paper, isn't it? I haven't got a calculator to tap it in. So 12's into 3,600. Well, 12's into 36 go 3 times, and then I've got 2 extra zeros, so it's going to be 300, isn't it? £300.
The height of Zach is 1.86 meters. He's a big boy. And height of Fred is 1.6 meters. Write the height of Zach as a fraction of the height of Fred. Give your answer in its simplest form. Write the height of Zach as a fraction of the height of Fred. That means Zach's height goes on the top and Fred's height goes on the bottom. So it's going to be 1.86 divided by 1.6. Now again, we've got decimals here, which we can easily get rid of by multiplying top and bottom by, well, let's do it by 100. So what will that give me? That will give me 186 over 160, won't it? So it's a top-heavy fraction. Right, so we're looking for common divisors now. 160 and 186. Well, struggling to find a common divisor. Bigger than 2. Let's just halve it and have another look. So that would be 93 over 80. Okay, any common factors there again? 3, no. 7, nope. No, I can't think of any more. No, I think that's about as far as I'm going to get with cancelling down. Now it's asking for the simplest form here, so we've cancelled down as far as we can. Now we could write it as a mixed number. We could write it as 1 and 13 over 80. But I don't actually think that is any more simple than this. I prefer to leave my answers as top-heavy fractions. I think they're more useful, so I'm going to leave it like that. Calculate 3/5 plus 5/8. Okay, so we're adding fractions together here, but you'll notice that we've got a different denominators. We've got a 5 here and an 8 here. So to add them together, we need to find a common denominator. So what's a common multiple of 5 and 8 then? The smallest one I can think of is, well, it's just 5 times 8 is 40, isn't it? So let's times the first fraction top and bottom by 8, and the second fraction top and bottom by 5. What's that going to give me? So that's going to give me 3 times 8 is 8, 16, 24 40ths, plus 5 times 5 is 25, 25 40ths. So now I've got two numbers with the same denominator. I can simply add the numerators together then. So the 24 plus the 25. That gives me 49 over 40. Okay, so that's an improper fraction, and in a lot of cases that would be perfectly acceptable.
It's just that in this particular case, it's asking me to express it as a mixed number, not as an improper fraction. So we're going to convert this into a mixed number by saying how many times does 40 go into 49? It goes in once, and the remainder is 9, so it's 1 and 9/40. Just double check, have we got any common divisors of 9 and 40? Nope, don't think so. So I think we're done. So it's 1 and 9/40. Write the ratio 6 millimeters to 180 centimeters in the form 1 to n. Okay. Now, when you're comparing things in a ratio, you should really have the same units, and these are not the same, are they? I've got millimeters and centimeters. So I'm going to have to convert them all into the same unit. It's going to be easier to go from centimeters to millimeters, I think. You should know that 1 centimeter is the same thing as 10 millimeters. So if I take the centimeter one and I multiply it by 10, I'm going to get millimeters then, aren't I? So the ratio is going to be 6 to 180 times 10. So that's 1,800. Okay. Now I want to have 1 here, which means I need to divide through by 6. So doing the same thing this side, dividing through by 6. 1,800 divided by 6. I can just do that in my head. That's 300. Okay. So write the ratio in the form 1 to n. It's 1 to 300. Adil, Kate and Rebecca share £160 in the ratio of 2 to 5 to 3. How much does Rebecca receive? Okay, so within these questions then we need to work out how many shares there are altogether. And we can do that by just adding the ratio bits together. So 2 plus 5 plus 3. That tells me that there are 10 shares altogether. Okay, now if there are 10 shares and we're sharing £160, then each share is going to be 160 divided by the number of shares, 10. So that's going to give me £16 per share. Okay, and then we've got in the ratio of 2 to 5 to 3 to start with. So scaling that up then by a factor of 16. That means that Adil is going to get £32. Katie is going to get £80. And Rebecca is going to get 3 lots of 16, which is 48. Now I've done a bit more work than I need to do here, but it's good practice just to double check your 3 amounts actually add up to what you started with, and 32 and 80 and 48 does add up to 160. So I'm feeling pretty confident that I've got my answer right. So £48 for Rebecca. The box contains only red, blue and green pens. The ratio of red pens to blue pens is 5 to 9, and the ratio of blue pens to green pens is 1 to 4. Calculate the percentage of pens that are blue. Okay, so I've been given 2 ratios here, and they're kind of separate from each other, aren't they? So what I'm going to do first is I'm going to try and combine them into one ratio that has all 3 elements in it. So I've got red, and I've got blue, and I've got green, haven't I? And I know from the first statement that the ratio of red to blue is 5 to 9. So I can put a 5 in there and a 9 in there. And then from the second statement, I know that blue pens to green pens is 1 to 4. So I can put a 1 in there and a 4 in there. Okay, so notice I've got 2 blue numbers. I've got a 9 and a 1. Now if I can take this second ratio, 1 to 4, and scale it up so that 1 becomes a 9, then I can kind of combine the 2 together. So that's what I'm going to do. I'm going to take this second ratio here, and I'm going to multiply it up by a factor of 9. And that's going to give me a ratio of blue to green of 9 to 36. Okay, and you'll see now that that 9 there matches with that 9 there. So that means I can bring down this 5 and write it in here. So I've got a kind of a super ratio now that's got all 3 bits included. So the ratio of red to blue to green is 5 to 9 to 36. Okay, now we know that, we can work out the percentage of pens that are blue, because we know that there are 9 blue pens for every 5 plus 9 plus 36 pens there are. So it will be percentage blue, it's going to be that 9 divided by 5 plus 9 plus 36 made into a percentage. Okay, so what's 5 plus 9 plus 36? That is 50, isn't it? So it's 9/50ths. Well, I might just make that into 1800ths and say that's 18%. By writing each number correct to one significant figure, find an estimate for this calculation. Now, it's really important that you read these sentences above the calculation. Some people just see this and they'll start focusing on that straight away and they won't read the sentence that goes above it. You really need to make sure that you do. This one is giving you some very clear instructions. They're asking you to estimate. I've actually given you more information than they need. They don't normally tell you this bit. So we're going to write each number correct to one significant figure. Even if they told me to estimate, that's what I would have done anyway. So a bit weird that they should tell you. But anyway, 606.3. What's that number correct to one significant figure? Well, the first significant figure is the first non-zero digit, which is that 6 there, isn't it? Which is in the hundreds column. So rounding 606.3 to the nearest 100 is going to be 600. Okay. And the second number, the first significant figure is the first non-zero digit. It's that one there. It's the 3. That's in the tenths column. So if I round off to one significant figure, I'm going to round off that number to the nearest tenth. So am I going to round up or down? Just look at the number next to it and decide whether or not it is 5 or more or 4 or less. In this case, it's 4 or less. So I'm just going to round down to 0.3. Finally, 19.93. The first significant figure is that 1, which is in the tens column. So rounding 19.93 off to the nearest 10, that's going to be 20 then, isn't it? So my calculation becomes 600 times 0.3 divided by 20. Okay. So let's do the maths then. What's 600 times 0.3? That's the same thing as 60 times 3, isn't it? So that is 60, 120, 180, 180 over 20. Just cancelling those zeros out. 18 divided by 2. That's going to give me an answer of 9. Okay, so that's my estimate. Write the number 6,005,200 in standard form. Okay, let's try and write it out as a number first off. So 6 million is 6 followed by 6 zeros. Well, 6,005,000, so that's going to be 005, 200, like that. 6,005,200. Okay, now we've got it written as a number. Now we can try and write it in standard form. So we're just going to write all the digits. 6.0052. I can forget about the last 2. So I'm not going to change it either way. So times what? 10 to the power of, well, if the decimal point starts here and we're going to end up 1, 2, 3, 4, 5, 6, we're going to move it 6 jumps to get it to there, aren't we? So that's times 10 to the power of 6. So my answer is 6.0052 times 10 to the 6. Match each sequence to its description. One has been done for you. You can see here we've got 1, 2, 3, 4, 5, 6 different sequences, and the first one is mapped as a Fibonacci sequence. It is, look, so 1 plus 1 is 2, 1 plus 2 is 3, and with a Fibonacci sequence you get the next number in the sequence by adding together the last 2. You can see that's the case all the way through there. What about the next sequence? I've got 1, 2, 4, 8, 16, 32. Now, from one term to the next, you can probably see that I'm multiplying through by 2. It's doubling each time, isn't it? It's times 2. So times 2 times 2 times 2. So anything that has a common ratio like that, multiplied through by the same number, that is a geometric progression. Next one, 1, 2, 3, 4, 5, 6. That one is going up in even jumps. It's plus 1 each time, plus 1, plus 1, plus 1. So any sequence that's going up in a fixed number each time, that's an arithmetic progression. Okay, what have we got now? 1, 3, 6, 10, 15, and 21. Now, if you drew those as a sequence of dots, I think you can probably see that this is the triangle numbers. It's that one there. 1, 4, 9, 16, 25, 36. I hope you can recognize is the square numbers, and that leaves me with the cube numbers 1, 8, 27, 64, 125, 216. Yep, that all looks good. Okay, all done. The nth term of a sequence is 5n subtract 2. Work out the third term. Well, if it's a third term, then that means that n must be 3. As n stands for whichever term is in the whichever position is in the sequence. So if n is 3, then 5n subtract 2 is going to be 5 lots of 3 subtract 2. 5 3s are 15, and 15 subtract 2, that is equal to 13. So it's that one. Expand 4 lots of 2d plus 5. So single brackets, a number on the outside, that gets multiplied by everything inside the bracket. So 4 times 2d is 8d, and 4 times 5 is 20. There's a plus sign in the middle, so it must be plus 8d plus 20. We're asked to factorize 15x plus 18y. Now that's pretty much the opposite of what we were just doing. Expanding removes brackets, and factorizing puts them back in. The thing that goes on the outside of the bracket is the thing that's common to both terms. So we've got an x in one and a y in the other, so they're not common, but we've got a 15 and an 18. 15 and 18 are both in the 3 times table, so I can put a 3 on the outside. Now, to work out what goes on the inside of the bracket, we just need to think about, well, what 3 times what is going to give me 15x? Well, 3 times 5x gives me 15x. I'm going to have a plus in between. And 3 times what gives me 18y? Well, 3 times 6y must give me 18y. So I get 3 lots of 5x plus 6y. Factorize x squared minus 9x plus 20. So we've got a quadratic expression, and we want to factorize it. If it factorizes, it will go into a double bracket like this, won't it? It starts with x squared, so I'm going to have an x and an x. Now I'm looking for a pair of numbers that multiply together to give me plus 20 and add up to negative 9. Okay, so thinking about the factor pairs of 20 first off. 20 you can get by multiplying 1 and 20 together, or 2 and 10, or 4 and 5. They're the factor pairs of 20. So we want one that adds up to negative 9. Okay, well, because I've got a positive number at the end and a negative number in the middle, I must have minus and minus, so these must all be negative values. Negative, 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 negative. And which pair adds up to negative 9? It's this one here. So it's going to be minus 4, minus 5. X minus 4, x minus 5. Solve x squared minus 9x plus 20 is equal to 0. Now that's the same expression as we've got above, so I can just factorize it the same way. X minus 4, x minus 5 is equal to 0. Now when you have two things that multiply together and give you 0, it means one of them must have been 0 to start with. So either x minus 4 is 0, in which case x is 4, or x minus 5 is 0, in which case x is 5. So my answer is x equals 4, x equals 5. Two solutions. Solve the equation 3x plus 14 is equal to 2. Right, so subtract 14 from both sides, or change sides, change signs to move the 14 to the other side. I'm going to get 3x. Those two things are going to cancel each other out. I'm going to get 3x is equal to 2. Subtract 14, which is minus 12. Then dividing both sides by 3. I'm going to get x is equal to minus 4. X is minus 4. Solve the equation 5x plus 1 is equal to 2 lots of x plus 4. So we want to get all the x's on one side and the numbers on the other. But let's try multiplying out this bracket first. Don't always have to multiply it. Sometimes you can divide by the number on the outside, but here we've got x's on both sides, so I think it's going to help to multiply it out first. So 5x plus 1 is equal to 2 lots of x, which is 2x, plus 2 lots of 4, which is 8. Okay, so you can see that we've got unknowns on both sides here. So let's subtract 2x from both sides. So that will leave me with 3x plus 1 is equal to 8. And we've also got numbers on both sides. So let's subtract 1 from this side and also 1 from here. That's going to give me 3x is equal to 7. And then dividing both sides by 3, I'm going to get x equals 7 over 3. Now 7/3, a top-heavy fraction or improper fraction like that is a perfectly acceptable answer. So you can just leave it in that form there. It's probably the easiest way of doing it. So just leave it like that. Rearrange x equals 2y minus 6 to make y the subject. Okay, so I've given this. You can do this pretty similar to how you would solve an equation, just trying to get y by itself basically. So we can start by adding 6 to both sides. That bit will cancel with that, leaving you with 2y on the right, and then x plus 6 on the left. And then we're going to divide both sides by 2. Okay, so then that cancels with that, leaving me with just y. Y is equal to x plus 6. I'm just going to leave it like that, x plus 6 all over 2. Okay, that's my answer. Y equals x plus 6 over 2. The rectangle has length 2x plus 5 centimeters and width x minus 2 centimeters. The rectangle has an area of 35 centimeters squared. Use algebra to find the value of x. Okay, so area of a rectangle is just length times width, isn't it? Okay, now we know the area. We're told it's 35. We know the length. It's 2x plus 5. We know the width. It's x minus 2. Okay, so solve for x. Okay, so we've got a quadratic coming on, haven't we? So we've got a pair of double brackets that we're going to need to multiply out. So that times that, that times that, that times that, that times that. So I'm going to get 35 is equal to 2x squared plus 5x minus 4x minus 10. Okay. Then what I'm going to do is going to collect everything on one side. So that 35, sitting there, I'm going to move over to the other side. So collecting like terms, 2x squared, 5x take away 4x is x, minus 10 with my other 35 coming over is going to be minus 10 minus 35, which is minus 45. And that's going to be equal to 0 because there's nothing left on the left. Okay, so I've got 2x squared plus x minus 45. Can I factorize that? I hope so. Okay, so common factor pairs of 45. Got 1 and 45, 2, no, 3, no, yeah, 3 and 15. 5's got to be in there, isn't it? 4, no, 5 and 9. 6, no, 7, nope. 8, nope. So, which one of those pairs is going to work? Now remember, I'm going to have 2x and x in here, so the order I put them in is going to affect the middle one as well, isn't it? I'm thinking it's going to be this pair here. Okay, because if I put the 5 at the end here, plus 5, it's going to be multiplied by the 2x, give me 10, and then the 9 here, which is negative, 10 subtract 9 is going to give me the 1 in the middle. So it's 2x minus 9x plus 5. Okay, that's equal to 0. So that's going to give me solutions of x equals 9 halves, 9 over 2 here, which is 4.5, or x equals minus 5. Okay, now does that make sense in this question? Because if x was minus 5, then up here, look, I would get 2 lots of minus 5, minus 10 plus 5, which is a negative number, and I can't have a rectangle with a negative value in reality, so that one is not a solution. Okay, it's a solution to my quadratic, but it's not a solution to this problem. Okay, so I'm just going to ignore that one. I'm instead going to use the x equals 9 over 2 or 4.5. Okay, so x is 4.5. Solve the inequality 3x divided by 2 is less than or equal to 9. Now, as long as we don't divide through by a negative number, we can treat these pretty much the same way as we solve any linear equation. So the first step I'm going to do is to take that 2 and cross multiply it. So move it across the equal sign, or not the equal sign, the less than or equal to sign. So that's going to give me 3x is less than or equal to 9 times 2, which is 18. 3x is less than or equal to 18, and then dividing both sides by 3 is going to give me x is less than or equal to 6. Okay, in the second part, solve the inequality 4 lots of x plus 2 is greater than 12. Okay, the first thing I'm going to do is divide both sides by 4 to get rid of that 4 on the outside of the bracket. So that's going to give me x plus 2 is greater than 3. And then moving this plus 2 to the other side, I'm going to get x is greater than 3 subtract 2. X is greater than 1. Finally, represent the solution set that satisfies both answers to part A and B on the number line. Okay, so from the first part we had x is less than or equal to 6. So x must be less than or equal to 6. And in the second part we had x is greater than 1. So x got to be between 1 and 6. It can include 6, but it cannot include 1. Okay, I'm going to show the range by drawing a line from 1 up to 6. So I'm going to draw a line from 1 to 6. Now the ends of the line depend on the sign. So if it's strictly greater than or strictly less than, we do an open circle. So at 1 I'm going to have an open circle. And if it includes the end point, like at the 6th end, we're going to do a filled circle. Okay, so because this sign is strictly greater than, we've got an open circle. And because this one is a less than or equal to sign, we've got a filled circle. On the grid below, draw the graph of x plus y equals 2 for the values of x from -3 to 3. Okay, so we need to work out our coordinates so we can plot this graph. Okay, now the easiest way to do that is to create a table of values. So pulling up a ruler, let's make a little table for our x values and our y values. Okay, so we know that this range goes from -3 to 3. Now you need a minimum of 3 points, but there's no harm in doing it a few more. So -3, -2, -1, 0, 1, 2, 3. Massively overkill. Probably only need 3 or 4. But anyway, it's not a very difficult question. So x plus y equals 2. That means y is going to be 2 subtract the value of x, rearranging that for y. So we can find the y value by taking the x value away from 2. So if x is 3, then y is going to be 2 minus 3. 2 minus 3 is -1. If x is 2, then y is 2 minus 2 is 0. If x is 2, then y is 2 subtract 1, which is 1. If x is 0, then y is 2 subtract 0, which is 2. If x is -1, then y is 2 subtract -1. 2 subtract -1 is the same as 2 plus 1, which is 3. I think you can see the pattern going on here. It's going to be 4 and 5, isn't it? Okay, so I've got -3, 5 to plot. -3, 5. -2, 4. -1, 3. 0 goes with 2. 1 goes with 1. 2 goes with 0. And 3 goes with -1. And notice they're all in a nice straight line. It was a linear function, so you'd expect it to be in a straight line. If it wasn't a straight line, you should be asking yourself some questions. Okay, so now they are all in a nice straight line. Let's pull in up a ruler and let's join them up. Now your line should stretch the full width of your graph. Shouldn't start and stop with the first point. The graph does continue in either directions, so your graph should show that. Okay, so there's my line. We're told that y is directly proportional to x, and we've been asked to complete the table. Now, if y is proportional directly to x, then y is going to be equal to k lots of x, where k is some constant that we can find. Now, we've got a pair of values that go together here. When x is 7, y is 63, so let's sub those in. So when x is 7, y is 63, so 63 is equal to k lots of 7. So that makes k equal to 63 divided by 7, which is 9. So our full equation is y equals 9x. So now very simple to fill out the rest of the table. If x is 0, then 9x is 0. If x is minus 8, then 9 lots of minus 8 is minus 72. All done. Y is inversely proportional to x. Complete the table. Okay, so y is inversely proportional to x. That means y is inversely proportional, little fishy, over 1 over x. Okay, so that's what that is saying mathematically. Now we can replace the little fishy symbol with equals k. So I'm going to rewrite that. So y equals k over x, where k is a constant that we can then find. Okay, now you can find the constant k if you've got two values, well, your value of x and your value of y that go together. Now we've got one of those in the table. If you look at this table, I've got two numbers here that go together. When x is 6, y is equal to 4. So sub in x equals 6, y is equal to 4 into my partial equation, y equals k over x. I should be able to find out what k is. So that becomes 4 equals k over 6, replacing y for 4 and x for 6. Okay, then just taking that 6 there, cross multiplying up there, or multiplying both sides by 6 if you'd rather, I'm going to get k is equal to 24, aren't I? Okay, so my complete equation then is going to be y equals k, which we've now found to be 24, over x. Okay, so now this is my complete equation, which I can then go and find my other values. So if x equals 12, then y is 24 over x. Y is 24 over 12. 24 divided by 12 is 2. So when x is 12, y is 2. And what about the other way around? So if y is 8, what is x? Okay, so if 8 is equal to 24 over x, just cross multiplying these two, just switching them around, I'm going to get x equals 24 over 8. 24 divided by 8 is 3. So x is 3 when y is 8. Once you've done a few of these proportional questions, they get very, very formulaic. They always start off by giving you the rule that links y and x. You can then form your partial equation, which involves the constant k. And then you'll have a pair of values that you can sub in to find what k is to complete the equation, and then you can go on and use your complete equation to find other values. They're always the same, very, very formulaic questions, and after you've done a few, you should be good on them. A, B, C and D, E, F, G are parallel lines. That's already been marked on. You can see by those arrows at the end at C and G. And it tells me that B, E, H is a straight line. Okay, so we've got a pair of parallel lines and a couple of lines crossing them. So we need to work out the size of angle X. Okay, so angle X is that one over there. How can I find that one? Well, when you've got a pair of parallel lines and a transversal or a line crossing them, then it forms various angles. and you should know about corresponding, alternate and co-interior angles. And I can see from here my X angle and my 25 angle are what we call co-interior angles. So this one and the X should add up to 180 degrees. Co-interior angles add up to 180 degrees, so 25 plus X is 180. So then taking 25 off both sides then should tell me what X is. So X is equal to 180, subtract 25, which is what, 160, 155, isn't it? So X is 155 degrees. And then B says work out the size of an angle Y. You must show your working, which may be on the diagram. Well, it will be on the diagram because I always do that. Okay, so where's Y? It's down there. There's Y. Look, we need to find that one. Okay, so again, we've got a pair of parallel lines, the yellow ones, and we've got this line here that crosses them, this purple one. Okay, so we should know that this angle here, the Y angle, corresponds to this angle up here. Now that angle up there is made up of the right angle, which is 90 degrees, plus the 25 angle, which is equal to 115 degrees. So Y and 115 are corresponding. So that is the answer. So I'm going to say Y corresponds to 90 plus 25 equals 115 degrees. 115 degrees. Here is a map of France, and we can see we've got several cities marked on the map, and we've got a scale down here. It says 1 centimeters represents 80 kilometers. Okay, what's the question ask? Over the page. What is the 3-figure bearing of Lyon from Bordeaux? The 3-figure bearing of Lyon from Bordeaux. So we're going to start in Bordeaux and we want to go to Lyon. Okay, right. So you'll notice at the top here we've got a direction line for north, and 3-figure bearings are always measured clockwise from north. So let's just get my ruler out. So straight up in the direction of that north line, look, that's north. So if I want to measure a bearing, I should really start by putting a north line on the point where I want to measure my bearing from. So I want to go directly north from Bordeaux. So drawing an up arrow from there. Okay, so that's my north line. And from Bordeaux, I want to go in this direction, don't I? Oop. Now, so using a protractor, what you want to do is you want to measure that angle in there. Okay, can't really show a protractor so well in this particular application, but if you plonk your protractor on and measure it, you should find that you get an angle of 84 degrees in there, 84 degrees, and then so to write that down as a bearing, 84 degrees has only got 2 digits. Okay, we haven't got 84. We've got 85 or 95 or 175 or 05. Okay, so I think perhaps I was just a little bit out of my measurement. I'm going to say it's that one there, 085. It says work out the actual straight line distance from Paris to Marseille. Work out the actual straight line distance from Paris to Marseille. So Paris is up there in the north, look, and Marseille is down in the south. So let's join them up with a straight line. Now with your ruler, you're just then going to measure that carefully then. Count the number of centimeters is between Paris and Marseille. Now again, because I'm using an emulated ruler here, I'm not going to be able to accurately measure it to show you, but if I did get a ruler out, I think it is around about 8.2 centimeters. Now if you're working from a practice paper from your school because they printed it out for you, sometimes these things don't get reproduced correctly at the right size, so you might find that yours is slightly bigger or slightly smaller. Don't worry too much about that. It's just one of those things that happens when schools give their students practice papers. What you just need to make sure you do is you take whatever measurement you've got there and you multiply it by the length to get the you multiply it by the scale factor in order to get the correct distance. So the scale factor is 1 centimeter represents 80 kilometers, and I've got 8.2 centimeters. Each one of those centimeters is 80 kilometers. I'm going to have to multiply these two things together. Okay, so again, using Napier's Bones grid, I'll do my 8.2 times 80. 8 eighths are 64, 2 eighths are 16, 8 zeros, well, 0 and 0. What's that then? Adding up along the diagonals, that's 0, 6, 5, 6. So reading around my answer, around the edge here, I've got the digit 6560. Now remember I had one number behind the decimal point there, so I'm also going to have one down here that's behind the decimal point. So my answer is 656.0 or 656 kilometers. So what is the actual distance? It's 656 kilometers. Again, if you're working on a reproduced practice paper that's been photocopied by your school, it might be that it got stretched or squished a little bit. So your answer might be smaller or bigger than that. Don't worry about too much. As long as you multiplied it correctly by 80, I'm sure you've got the... The diagram shows triangle ABC. Construct a bisector of angle BAC, then construct the perpendicular bisector of AC, and then shade the region inside triangle ABC that is nearer to AC than to AB, and nearer to A than to C. So we need a straight edge and compass for this, so let's get busy with that then. Okay, first up, make sure your compass is set up correctly. You need to have the pencil tip and the tip of the compass in the same place before you tighten it up. It's a good idea to keep yourself a little stumpy pencil like this one, so that you can swirl your compass all the way around without bumping into your hands. Okay. Then what we need to do is, what we've got to do, we've got to construct a bisector of angle BAC. So this is B, A, and C. So the angle BAC is this angle here. We need to cut this in half. Okay. Now to do this, you stick the compass tip at the angle, so in A, and we're going to draw an arc that cuts both those two arms of the angle. Okay, then we need to move our compass tip into that place where we cut it, and then into that place where we cut it and draw two extra arcs. Now those two will make a cross, and then we can then just join point A through that cross that we've made. Okay, now it doesn't matter what width you set your compass to, just that you don't move it while you're doing the construction, so you need to try and keep it the same. If you know it's moved, you probably want to stop and try again. Now, that seems to be a pretty good job. You can always check that with a protractor to be sure you've done a good job. Alright, next, construct a perpendicular bisector of AC. This is AC, so we want to cut this line in half. Now to do it, we need to set our compass so that it's slightly more than half the distance between the 2 points. Between half and 2/3 of the line is a good distance. Okay, and then we're going to draw two arcs from C and from A, and then hopefully they'll cross. I'm going to struggle a bit because it's going off the bottom from my paper here. So bear with me. Okay, so there's one of the arcs. Now move the point over to A and draw the second arc. Okay, I haven't quite got the arc, the cross at the bottom there. Let me just extend that one a little bit. Okay, there we go. So then those two arcs make 2 points of intersection, which you can then join up with your ruler. Okay, oh, I've got my ruler the wrong way around. You can see it's an awesome Pokemon ruler today. Okay, so there's my second line. So we want to shade the region that is inside triangle ABC that is nearer to AC than to AB. So nearer to AC than to AB is going to be below this angle bisector then, isn't it? And nearer to A than to C is going to be the left-hand side of this perpendicular bisector. So the area that we want is this triangle in here. So it's below the angle bisector and to the left of the perpendicular bisector. All done. Good job. In the diagram, the area of triangle ABD is 56. Work out the length of CD. Okay, in the diagram, triangle ABD. What is triangle ABD? Triangle ABD is ABD. It's this triangle here. And we're told that the area of this one is 56 centimeters. Now, we know that the area of a triangle is half its base times its height. So, area of triangle is half base times height. So, we know that the baseline of this triangle is 14, but we don't know the height. Let's call the height h. Okay, let's call it h. So, then my area of my triangle, which I already know is 56, is going to be a half times my base, which is 14, times my value of h, which I'm actually trying to find. Okay? Right, what can we do with this then? So, half of 14, that's 7, isn't it? So actually what I've got here is 56 equals 7h. And then dividing both sides by 7. Sevens into 56 go 8 times. So that means that h is equal to 8. Okay? So now we know how tall this triangle is. It's 8. Now we want to find the length CD, which is this length here. Okay? Now, looking at the right triangle, that has got a length of 6 and a height of 8. So I want to know the hypotenuse of that right angle triangle. Now, you can do this with Pythagoras Theorem. I already know the answer because I know that 6 and 8 goes with 10. Okay, so I know already that it's 10 because I know what are the Pythagorean triples. Now these are very handy triples to know. So the first one is 3, 4, 5, and then any multiple of that is also a Pythagorean triple. So if you double each of those, you get 6, 8, 10. There's another one, 5, 12, 13. And knowing those means that if you have got a problem that involves Pythagoras Theorem on the non-calculated paper, you can pretty much always work out what these are without even having to think about it. But let's assume you didn't remember the Pythagorean triple. You'd have to use that c squared was equal to a squared plus b squared, wouldn't you? So c squared equals a squared plus b squared, which in this case would be 6 squared and 8 squared. 6 squared is 36, 8 squared is 64. Adding them together, you're going to get c squared is 100, making c equal to 10. So my answer is 10 centimeters, as I already told you. Okay, in the diagram, ABC is a right angled triangle. P is a point on AB. BC is 40 meters. AP is 20 meters and angle ABC is 30 degrees. Okay, now I do suggest you read through this information above the diagrams carefully and just double check that everything written up there is on the diagram. In this case it is. I've got the BC is 40, I've got AP is 20, and I've got the angle and I've got the right angle marked. But it isn't always the case, and it's always worth just double checking, because otherwise you might be staring at a problem that you can't solve because you don't have all the information. Okay, but all the information is on the diagram here, so we can proceed. Show that AC is 20 meters. Where's AC? AC is this side here, isn't it? I need to find that line, AC. How can I do it? Well, if we look at triangle ABC, that's just a right angle triangle, and I know an angle, 30 degrees, and I know a side, hypotenuse, so I can find a second side, no problem, just using trigonometry, can't I? Okay. So if 30 is the marked angle, then the 40 degrees, that's the hypotenuse, isn't it? And AC is the opposite, and AB is the adjacent. Okay, so time to think about our mnemonics, SOHCAHTOA. SOHCAHTOA. Now, we have got a hypotenuse and we want the opposite. So which one is about O and H? It's the SOH part, isn't it? SOHCAHTOA. So that's the sine of an angle is equal to the opposite over the hypotenuse, if we're writing that out nice and long. Okay, so we're going to write out the correct trigonometric ratio. Next thing is to sub in what we know. We know the angle is 30, so let's put that in. So sine 30 is equal to the opposite. That's what I want to find. It's the side AC. And then hypotenuse we know is 40. So rearranging, multiplying both sides by 40, we'll cross multiply that 40 from where it is to the other side. So I'll get AC is 40 sine 30. Okay. At this point, you'd reach for your calculator and then realize, oh, I don't have my calculator. This is the non-calculator paper. So am I stymied? Nope, because you should remember your exact trig value, shouldn't you, for angles 0, 30, 45, 60, and 90. If you didn't remember those, why not? You need to know them for your exam, don't you? Okay, there are various ways of remembering these values, but you should remember that the sine of 30 is a half. Okay, so I'm going to replace sine 30 from my knowledge bank of sines and cosines that I need to remember and sub it in. Okay, so 40 times a half is equal to AC, so that makes AC equal to 20 as required. Triangle A and triangle B are drawn on the coordinate grid. Yes, they are. Part A says, draw the image of triangle A after a rotation of 180 degrees about the point 0, 0. Okay, so one way of doing this, if you're not very good at rotations, would be to go and ask the invigilator for a sheet of tracing paper. Lay that over the top of your diagram. Next, what you want to do is to put a little cross where the center of rotation is. At this point here, it's at 0, 0, isn't it? So if you put a kind of a cross going through 0, 0, it will help you keep track of your rotations. Then you want to put your pen tip or your pencil tip at 0, 0 and turn the paper round. Okay, so when you get that little cross line up again for the first time, you'd have done a 90 degree turn, and then let it go around one more time so it lines up one more time, and you've got a 180 degree turn. Now, when you've got a 180 degree turn, they don't bother telling you if it's anti-clockwise or clockwise, because you're going to land in the same place. In this case, I'm going to have the points as indicated here. So I'm just going to remove the tracing paper carefully and put the image points in. So my 3 image points are going to be here, here, and here then, aren't they? Okay, so just carefully put the image points on, and then once you've got the image points on, you can then join them up with a ruler. Like so. So rotation, it should change the orientation and position of your shape, but not its overall shape, because it's still the same shape, it's just kind of upside down and move to a different quadrant. Okay, so that's my rotation. The next thing we need to do is to draw the image of a triangle after a transition of by the vector 2, -7. Well, a vector 2, -7, if you were going to draw that vector, it would be 2 along and 7 down. So I need to take each one of my points and move it 2 units to the right and 7 units down. So let's take this point here first of all, go in 2 units to the right, and 1, 2, 3, 4, 5, 6, 7 takes me to that point there. Okay, just going to rub that out again. So, okay, similarly, this point here is going to be translated to that point there, and this point here is going to be translated to that point there then, isn't it? Okay, once you've got your corners, then you can join them together with your ruler again. Part B says, describe fully the single transformation that maps triangle A onto triangle B. Now this is a 3-mark question, so you expect to give 3 bits of information in order to get to the mark. Let's go back and have a look at the diagram. You can see A and B, they're sitting next to each other. A is bigger than B. Remember, A is the original image object though, and B is the image. So A has been translated onto B. So I think this is going to be an enlargement. It's one of those crazy mathematical enlargements where your image ends up being smaller than the object. Okay, but we still call that in maths an enlargement, weirdly. But anyway, let's draw on some ray lines. Pick 2 points that go together. So this point here matches up with this point here on the image. So if I draw a ray line through those points, I'm going to use green. So like so. Just draw these faint really, and then I'm going to do the same. I'm going to find another 2 points that go together, so that tip of the triangle goes with that tip of the triangle down there, doesn't it? So I can put another ray line through those 2 points, and you should find that your ray lines converge on a particular point, and that particular point is known as the center of enlargement. In this case, it's this point here, isn't it? And that is the point -1, 2. Okay, so that's my center of enlargement. Now I need to give 3 bits of information. It's an enlargement is one thing. It has a center of enlargement at -1, 2. That's the second thing. And the third thing is going to be the scale factor. Now notice that this line here is 4 units and its matching side is 2, which is half as big. So that's telling me that the scale factor is a half. Okay, so they're the 3 things that I need to mention when I describe this transformation. It's an enlargement, 1 mark. Center, -1, 2. Scale factor, 1/2. Okay, they're my 3 bits of information for my 3 marks. 50 people took a test. Before the test, they predicted whether they would pass or fail. 30 people predicted they would pass. 26 of the people who predicted they would pass did pass, and 37 people passed altogether. Complete the frequency tree. Are you predicting that you're going to pass this test? Right, so 30 people predicted they would pass. So prediction, 30 people predicted they would pass, so 30 goes here. So if there's 50 altogether, then in the fail box it's going to be 50 subtract 30, isn't it? Going to be 20 people in there. So 30 people predicted they would pass and 20 predicted they would fail. Okay, so I've dealt with that first line there. 26 of the people who predicted they would pass did pass. So out of my 30 people who said they would pass, 26 did pass. So then that means that 30 subtract 26, or 4 of them thought they would pass, but they didn't, they failed. Okay, and it said 30, so we dealt with that one now, haven't we? So, and then finally 37 people passed altogether. So I know that 26 people passed up here, and I know that 37 people passed altogether. So 37 subtract 26 is the number of people who passed who thought they were going to fail then. So 37 subtract 26 is 11. So if 20 people thought they'd fail but actually passed, that means 9 people who thought they failed did fail. 20 subtract 11 is 9, isn't it? Okay. Beth uses these 4 cards to make 4-digit numbers. How many different 4-digit numbers can she make that are greater than 8,000? Okay, Beth, what are you going to do here? 2, 4, 5, and 8. So we've got 4 places to fill. Let's think about what choices we have for each of these. Now, my number needs to be greater than 8,000. So I don't have a lot of choice for the first digit. It's going to have to be this one here, isn't it? It's going to have to start with an 8. So it's 8,000 and something. If it starts with 2, 4, 5, it's going to be less than 8,000, so it's no good. Okay, so it has to start with the 8s. That was only one choice I had for that. Right, what's the next digit? The next digit could be any of the other 3 numbers. So I've got 3 choices for that one. It could be the 2 or the 4 or the 5. So let's say I pick the 2. How many choices have I got left for the next choice? I've got 2 choices. Let's say I pick the 4. How many choices have I got left for the last one? I've only got 1. Okay, so then we can work out the total number of ways by then multiplying those choices together. So 1 times 3 times 2 times 1 should give me the number of ways of working out altogether. So 1 times 3 times 2 times 1 is 6. So there are 6 different numbers greater than 8,000 that she can make. Another way of doing it would be an exhaustive approach where you just wrote down all the various values until you had all the different ones. So 8,245, 8,254, etc. Until you got through all of them. Either way, you're going to get 6 values. Hannah wants to display all the possible outcomes when rolling 2 fair 6-sided dice. Give a reason why a tree diagram is not the best method to use. Well, in a tree diagram, you're doing a branch, aren't you, for every possible outcome. So when you throw the first dice, you're going to have 6 possible outcomes. So if you were going to draw this as a tree diagram, you'd have 1, 2, 3, 4, 5, 6 different branches like that. And then each of your branches is then going to have 6 more branches. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's gonna be like a forest, not a tree, isn't it? So there's so many branches at the end. It's just confusing. So the reason why I wouldn't use it is that it is too many branches. So draw a sample space to display all the possible outcomes. That's a much more sensible idea, isn't it? Now a sample space, you're going to have a table, and you're going to have a column for each outcome from one event and a row for each outcome from the other. So I can get a 1, a 2, a 3, a 4, a 5, or a 6 on my first dice. I can get a 1, a 2, a 3, a 4, a 5, or a 6 on my second. Now, what you put in the middle depends on what the question is. Now, if it was the sum of the 2 dice, then you'd put the sum in the middle, so 1 plus 1 is 2. If you were subtracting, 1 subtract 1 would be 0. So it really depends. Now in this case, I can see in the next question that we're looking at adding them together. So I'm going to put the sums in the middle here. So 1 plus 1 is 2, 1 plus 2 is 3, 4, 5, 6, 7. 2 plus 1 is 3, 2 plus 2 is 4, 5, 6, 7, 8. 3 plus 1 is 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. And 7, 8, 9, 10, 11, 12. Okay, so that's my sample space for adding the two scores together. And then in the last part here it says show that the probability of the score of the two dice adding to 11 is 1 over 18. Okay, well, there are 36 outcomes altogether. Now probability is equal to successful outcomes over total outcomes, isn't it? That's the definition of probability. In this case, there are 36 different outcomes, each one of those numbers in the sample space. 6 times 6 is 36. So that's the number on the bottom. And how many 11s can we see? Well, I can see one there and one there. So that's 2 altogether. So there are 2 successful outcomes out of 36. Dividing top and bottom by 2, that's going to give me my 1 over 18 as requested. 2 ordinary fair dice are rolled. Complete the tree diagram. Okay, so we've got our rolls for the first dice on the left, and the probability of getting a 4 is 1 over 6, and we know that the probability then of not getting a 4 is going to be 5 over 6, because all the branches of each part of a tree diagram should add up to 1 because of completion. So again, up here that should be 5 over 6, 1 over 6, and 5 over 6. Okay, so then circle the probability that both dice land on 4. Now both dice land on 4 is this root here. So that's the probability of 4 and 4. Probability of 4 and 4 is going to be those two values multiplied together. Then it's going to be 1/6 times 1/6, which is 1 over 36. Is that one there? Part C asks us to work out the probability that at least one of the dice does not land on 4. Now the probability at least one not 4, that's basically 1 minus the probability of them both being 4s, which is 1 minus 1 over 36, which is 35 over 36. Now you could do it the long way and work out that root, and that root and add them up, but because all of the outcomes add up to 1, if I know the first one, I can just take it away from 1 and it will give me the remainder.
Phew, well that was a long session. Well done for getting all the way through to the end. Please do like and subscribe if you found it helpful, and share the link with your friends. This really helps the channel out. Past paper practice is one of the best forms of revision in the run-up to the exams, so be sure to check out my past paper walkthroughs by checking out the playlist linked on your screen. See you on the next video.